second law of thermodynamics. The second law of thermodynamics says that in any spontaneous process, there is always an increase in the entropy of the universe. And that entropy of the universe is always increasing. Entropy is increasing, but the total energy of the universe is constant. Thus the law of conservation of energy. We can calculate S of the universe if we add the delta S of the systems and the surroundings. So together we have the entire thing. Let's describe the following as spontaneous, non-spontaneous, or cannot tell in these particular situations. Let's look at a reaction that is exothermic and becomes more positionally random. So positionally random means more random, or positive delta S. Alright, so let's think about this. We have an exothermic reaction, and an exothermic reaction is one that is a negative delta H. That's a favorable situation. More random is also favorable. That's the positive delta S. Therefore, this one is always going to be spontaneous. Let's look at the next one. Exothermic and less random. Well, here we have negative, got to go back to that pen, negative delta H, which is good, and a negative delta S. This is one of those maybe situations. In other words, if the energy is more important than the entropy, the reaction will happen. But without any more information, we can't tell. Endothermic reactions. Now, these are ones where you have a positive delta H. It doesn't look too good for that. But it becomes more random. That's a good thing. Now, we can't really tell here. Only if the randomness of the particles is more important than the energy does the reaction happen. But again, without any more information, we can't tell. And finally, endothermic reactions that become positionally random. So how do we do that? Well, endothermic, we already know, is not a good thing. Not favorable. Less random. More orderly. Also, unlikely to happen on its own. So if neither factor is favorable, then this reaction is not going to happen spontaneously. Now, it doesn't mean this reaction is not going to ever happen. It just means it won't happen without intervention, some sort of outside source. Let's talk about delta S. The sign of delta S surroundings depends on the direction of heat flow. And the size of it, of course, depends on the temperature. Usually we're interested in the value of delta S. In the back of textbooks or in your reference books, you can find values of delta S for all kinds of different substances, including elements. How do they calculate that? Well, delta S is the quantity of heat divided by the temperature, joules per Kelvin. In an exothermic process, the delta S is positive. In an endothermic, the delta S for surroundings is negative. Because if something is taking in energy, for example, and is endothermic, that which is around it loses energy. If you are losing energy, then what's happening? You are slowing down, and that becomes more orderly, which is against randomness, or negative delta S. Now, just because something isn't random doesn't mean it's not going to occur. There's another factor, delta H, that helps us. And we can also think of heat this way, or delta S this way, the change in H over T. This is the idea we had in intro when we were talking about if one is favorable and one is not favorable. This, however, is focusing only on entropy. Notice if the universe is positive for spontaneity, the reaction will happen. If not, the reaction will not happen, or it might happen. Again, it depends on the magnitude of those particular numbers.